This is video number 13 for Computer Science 1124. Meanwhile, back at the sorting algorithm, this is a rewrite of the multicolor pieces we had. Here's the general idea. We're going to have a big loop that encompasses everything else in this entire algorithm that says while at least one swap occurred, then we got to go through the list again. For each consecutive pair of elements in the list, that means we're going to loop through the whole thing from front to back. What do is we're looking at each pair. We check each one. If the first element of the pair that we're looking at is greater than the second element in that pair, then we swap them. What's missing from all this was something that's going to help the while loop figure out whether or not any swaps occurred. And at the very end of the last video, I said, you know what? Let's think about using a flag variable, which is a variable that is only ever set to true or false, and it indicates whether or not something that we were watching out for ever occurred. What are we watching out for? We want to know whether or not any swaps ever had to occur. If a swap occurred, that means we found a pair of numbers that was out of order, and that leads to the possibility the entire list could still be out of order. So if any swaps occur at all, we need to set that flag. And here we go. Set swap flag, for lack of a better name. Set swap flag to true. Why? Well, we found a pair of numbers that was out of order. So not only do we need to put those in order, we need to communicate later on with the while loop to say, we found a pair that was out of order. You're going to have to go through the whole thing again. So now we need to modify, I don't know why I close up these markers. Now I need to modify my while loop. I can be more specific about that. This is pretty generic. While, something to do with the swap flag. While swap flag is still true. Well, I don't know that still is something we could put into a while loop. I'll just say while swap flag is true. There. Now we've got a condition, almost a condition, that is turns into double equals. We see if it's exactly equal to true. If the swap flag is true, that means the list is still out of order. So we got to go through all the numbers from front to back, and every pair we find it out of order, we set swap flag to true. Every pair, which could be one pair, which could be 10 pairs, which could be 30 pairs. The number of pairs that we have to swap doesn't matter. One is as good as a million. I said that in one previous video. So now even my videos are repeating themselves. Which begs the question, when does swap flag ever get set to false? When do we initialize it to false and say, you know what? I haven't had to swap any pairs yet. Certainly that would be true up here, right? Set swap flag to false. But look what happens there. If I set swap flag to false right here, then it skips the while loop completely. And my algorithm doesn't do anything at all. Think about that again. If I say set swap flag to false, then if my loop condition is while swap flag is true, then it's not going to execute any part of my while loop ever. So that's not a good place. Set swap flag to false, maybe right before the green statement. But look what that's going to do. That's not going to tell me about the entire list. If I do that inside the for loop, then setting swap flag to false is only going to tell me about the pair I'm about to look at right now. It doesn't tell me anything about the history, whether or not I had to swap anything earlier on in the list. So somehow or another, I need to set swap flag to false right before I start going through the list. Because at that point, I don't know if I'm going to have to swap anything this time through. So that leads me to ask, where do I start going through the list from front to back? Here's the answer right here. Every time I start this for loop over again, it's going to start off with I equal to 0. It's going to start off with the very first element. Right before I start looking at all these pairs again, going through the list, I need to set the swap flag to false. What that swap flag, let's be more specific. What the swap flag really means, it does not mean did I ever have to swap anything anytime in the execution of this entire algorithm. What it really means is, did I have to swap anything this time through the list. This time through the list starts right here. For each consecutive pair, starting at the very first one. So here's where we start going through the list. So it's right before that I need to set swap flag to false. And that's such an important point. I'm going to say it again, like everything else I've been saying again. Set swap flag to false. Why would I do that there? I need to set swap flag to false right before I start all over again going through the list from front to back. This is where that happens. While swaps keep occurring, then I turn around right before I start looking at the consecutive pairs again. I set the swap flag to false because until further notice, no swaps have occurred this time through. So I set it to false. Here we go through the list. 1, 2, 3, 4, 5, 6, 7. Oh no, I found a pair I have to swap, so I swap them. So I set the swap flag to true. It happened, a swap occurred. On the other hand, what if I go through the entire for loop, looking at consecutive pairs of elements in the list, and this if condition is never true? If the if condition is never true, then it never swaps anything and it never sets the swap flag to true. So swap flag will still be false on a clean pass, also known as a clean iteration through the list. As I go through the list, if I don't have to swap any, this flag never gets set to true. I never saw that event that I was watching for. There's still at least one unanswered question about the flag. How does it get to true in the first place? Ladies and gentlemen, here is the most confusing part, in my humble opinion, most confusing part of this entire algorithm. We got to prime this while loop up here. We got to make it execute at least once. So it's got to at least look at the list. So we got to lie. Set swap flag to true. We haven't even looked at any pairs. That's a big fat lie. Set swap flag to true. No swaps have occurred. Then why do we need to do that? We have to do that to make sure that this while loop condition is true the first time we get here. It might not be ever again, but it's got to be the first time we get here, or it's not going to do any of this stuff down here. And if it doesn't do any of this stuff, we don't know whether the list is in order or not. And I wish I could make that even less confusing, but unfortunately I cannot. This is confusing. Why would we set the flag to true when it hasn't even happened yet? For specifically the reason of make this while loop condition true the first time. That forces it to look through the list with the for loop and swapping things out of order. Even if the list is already in order, it still needs to go through the list one complete time to realize that. Now, this is almost a stepwise algorithm. There is, I'm going to say, one missing piece. We have to provide some input to our algorithm. Assume an input list. Now that doesn't necessarily mean input from the keyboard. That might be where we got it, but that's not the input that it's referring to. This input list is a list that is input to this algorithm. This is now a thing. That algorithm, that is an algorithm. I didn't put all the numbers and everything, but that's stepwise, and we actually can convert that to Python now. Assume an input list, then go. Turn this loose on the list and see what it does. And there we will have it. And you will have it. It's in the code attached to the email that has links to these videos. One thing I need to mention about the code, I hate slipping this in as almost an afterthought. Oh, first of all, are there any questions about the bubble sort algorithm? Except where did I come from? Where did that name come from? This is called bubble sort. B-U-B-B-L-E-S-O-R-T. And I don't know that anybody's ever necessarily explained that to me, but I think it's because as you're switching the numbers as you go through, it's like little bubbles. If the quarantine is getting to you and you have to drink Alka-Seltzer regularly, then you're familiar with the idea of things bubbling up. And here, things will bubble to the end of a list if they're large, bubble to the front if they're small, with all the swapping there. That is way more than I needed to say about that. But there is one more thing that is a gigantic programming thought, concept, idea, mechanism, all that stuff. But I'm just going to toss it here as almost an afterthought, a function. How do I get away with tossing in something so big and in such a small little piece of the board? I'll just do this by fig. Here's a fig. We've been using functions ever since we started Python. Here's our main program. Well, wait, I don't remember ever using a function. Yes, you did. When you said eval input. Input. Here's the signal of a function. If you see something that ordinarily would be just like a normal variable or something like input, if there's something in it in parentheses, then what you're doing is calling a function. It's like a separate miniature program that does its own thing to help out your program. So it temporarily leaves executing your program, goes over here and does whatever it needs to do for input, and then comes back and picks up where it left off. And you do some more computing, oh, I'll find the average, I'll do all that stuff, yada, yada, yada. That's the execution path of your program, by the way. And it gets down here, oh no, another function call. I feel another function call coming on. I want to print out some results. Print. Again, you'll remember, has parentheses. Functions everywhere. Circle dot draw. You put the window, the graphics window in parentheses, that's a call to a function. It temporarily leaves your program, does whatever it needs to do, and comes back. Picks up where it left off. Why am I talking about this now? Well, the implementation of bubble sort that you'll see in Python, rather than clog up the main program with all the technical difficulties, I just broke this off and made a function out of it. So that's actually, I think, our first example of our own homemade function. But it will temporarily leave the main part of the program, go over here to the sorting algorithm implementation, also in Python, put that list in order, and then come back and pick up where we left off and go to a happy ending of the program without crashing, ideally. That is functions in a very, very cursory overview, nutshell. But that's what's going on. And the only reason, again, that I introduced functions so late in the game is because it just makes it a lot easier to isolate this so we can focus on just the steps of the algorithm without bothering ourselves with what's going on in the main program. Okay? Well then, that's a lot of stuff, isn't it? Look through this carefully, think about it, think deep thoughts, write your notes, work on the lab, and come in during office hours, 1 to 2. I automatically get cut off at 2 o'clock. So the office hours are 1 o'clock till 2 o'clock, and if that's not a reasonable range, then send me an email. We can set up a separate Zoom meeting just for us. But I'll see you online.